بسم الله الرحمن الرحيم. أبنائي وبناتي، بنبدأ مع بعض شرح منهج Act 2 Physics. أول موضوع بيقابلني Kinematics يعني معادلات الحركة. Kinematics is the study of how things move, like we will deal with position, distance, displacement, and the difference between them, how fast they move. We will speak about speed and velocity and difference between them, and also the rate of a change in velocity, what we call it acceleration, and how much time passes during these changes. Distance, مسافة, like the distance between these two lines. It has, imagine, 2 centimeters. So distance is the total length moved, and it is a scalar quantity. Scalar quantity means has magnitude only. Okay. Displacement, imagine that I have like a box here and I move it, so it is displaced for a new position, right? I can make this displacement up or down, right or left. So I can move this box 2 meters right or 2 meters left, up or down. So displacement has direction. It is also length. We define it as a straight line distance between 2 points. The change in object position. So the displacement is a straight line distance between 2 points, or the change in object's position, and it is vector quantity, has magnitude and direction. And we can say about it, it is the shortest line between the start and end points. We give it a symbol delta x, so it equals final position minus initial position. Sometimes we give it the symbol s, and for the distance the symbol d. Okay, let's imagine we have a line here. This is the origin. This is 1, 2, 3, 4, and this is -1, -2, -3, -4. Imagine that we move from 1 to 3. So x initial equals 1 and x final equals 3 meters. So the distance here equal from 1 to 3, we moved 2 meters, right? About calculating the displacement, delta x equals 3 minus 1, the final position, minus initial position, so it equals +2, right? And the direction right, toward right. Imagine that we make the x initial equals 3 meters and the x final equals 1 meter. So distance is the same, 2 meters, because we don't care about the direction when we deal with the distance. But displacement equals final position minus initial position, it equals -2. Negative means toward left. Okay, so if you don't change the direction of the motion, the distance is the same as the displacement. If you move in one direction, so distance equals displacement. Let's take another example. Imagine that you move the 3 meter right and 4 meter up from A to B to C. Calculating the distance equals here, or let's write it here. Distance equals from A to B to C, 3 plus 4 equals 7 meter. About displacement, you can call it S or delta X, whatever. It is the shortest line between the initial and final points, between start point and final point. So this is what we call the displacement. And from Pythagoras, it equals 3 squared plus 4 squared equals 5. And if you have direction like that, this is north, east, west, south. As you see, it is between north and east. So the direction will be north of east. And you can calculate the angle. We will see in some problems how to calculate the direction exactly. Let's take another example. Like this example, you move from A to B to C to D, and the length here is imagine it is 2 meters for the square, the length of one side. So the distance from, imagine you move from A to B to C to D and return back to A. So the distance equal 2 plus 2 plus 2 plus 2 equals 8 meter, right? But the displacement, you start at point A and end at point A. So the displacement equals 0 because the start point is the same as the end point. Got it? Another example, imagine that you have like a circle and you move from here, from A to B, and its radius R. So you move half the circumference, right? So distance here equal 2 pi r over 2, so it equals pi r because the circumference 2 pi r, you move half it, so only pi r, right? And the distance, the displacement here, the shortest line between the start and the end points, so it equals 2r, the diameter. Got it? Also, if you have the same cycle and you start from A and end at the same point A, so distance equal 2 by r, but displacement, as you know, equals 0 because the start point is the same as the end points. Speed, سرعة, average speed, السرعة المتوسطة, it is the total distance a moving object covers divided by the total time it takes, and it is scalar quantity. It has only magnitude or numerical value and it doesn't have a direction. So how to calculate average speed? V equal distance over time. and its unit meter per second, the SI unit meter per second. For velocity is speed in specific direction or speed with direction. Okay, so average velocity is the change in position divided by the change in time. So v average velocity equal, we can say delta x or delta s over t, and it equals x final minus x initial over change in time or time t, and it has the same unit meter per second. Okay, so you divide displacement over time to get the velocity, average velocity. Here you divide distance over time to get the speed. As we said, speed is the magnitude of the velocity, doesn't have direction. Speed is a scalar quantity, while velocity is a vector quantity. Both have same unit meter per second. Acceleration. Acceleration is the rate of a change in velocity. So the rate of a change in velocity, so A equal dv by dt, or delta v over delta t. So it's unit meter per second square or meter per second, because delta v meter per second and the time second, so meter per second square or meter per second. As you see, velocity is the rate of a change in displacement. So v equal delta s over t. Okay, but acceleration equals the rate of a change in velocity, so delta v over t or delta t. Okay, if the object have a uniform speed or constant speed, its acceleration equals 0, because acceleration is the rate of a change in velocity. What if the velocity is constant or uniform? So the acceleration is 0. Acceleration may be positive or negative or 0. You know when the acceleration is 0 or when the object doesn't change the speed. Its speed is constant, uniform. If its speed, velocity increases with time, so it accelerates. But if its velocity decreases with time, it decelerates or slow down. The kinematics equation for uniformly accelerating motion. The kinematics equation relate distance, position, displacement, velocity, acceleration, and time to each other. These equations are so important, you have to know it. The first to calculate average speed, V average equal d over t, right? D over t. So distance equal V average times t. You have to know this equation. And how to calculate V average? V average equals V initial plus V final over t, means initial velocity plus final velocity over t, or we can write it as half V initial plus V final. So we can use it here. So distance equal half V initial plus V final times t. This equation is so important because you can use it when you don't have the acceleration, right? As you see in the problem, we have distance, we have final speed, initial speed, and time. We don't have acceleration, so it is good to use it when you don't have or you don't know the acceleration. Acceleration equal delta V over T or V final minus V initial, the change in speed over time. So from here we can write this equation. As you see, AT equals V final minus V initial. So V final, since this with a opposite sign here, so V initial plus AT. We have two more equations, that V final square equal V initial square plus 2A. You can write here D, the distance or the displacement. Okay, guys, and you can write this equation to get what you need by sending V initial on the other side. So V final square minus V initial square equal 2AD. So from this way you can calculate the acceleration or the distance depending on what you need in the problem. A equals V final square minus V initial square over 2D, and also you can write it as D equals V final square minus V initial square over 2A, depending on what you have and what is given and what you want to get. The last one here, D or S, whatever you deal with, distance or displacement, equal V initial T plus half AT square. As you see here, it has initial speed, time, and acceleration. Here we have final speed, initial speed, and distance and acceleration. We don't have time here, right? So which one you will use to solve a problem depending on the given information and what he asks for. Let's move to the free fall. Free fall, when you neglect air resistance, when there is no air resistance, when the only force effect on the body is the gravity. An object is in free fall if it is under the influence of gravity. Any object, regardless of its mass, don't worry about the mass of the object. Different masses fall with the same speed and reach the ground at the same moment if you neglect air resistance. So, any object, regardless of its mass, falls near the surface of the Earth with an acceleration 9.8 meter per second or 9.8 meter per second square. We will round the free fall acceleration g to 10 meter per second or 10 meter per second square. Free fall's acceleration assumes that there is no air resistance to embed the motion to oppose the motion of the falling object, unless you told differently for a particular question. Since the free fall acceleration is constant, we may use the kinematics equations to solve problems involving free fall. The same equation, motion equation, those, but instead of letter A, we will use letter G, 9.8. So we simply replace the acceleration A with G in each equation. Okay, guys, like V final equal V initial plus, instead of AT, GT. Okay, like V final square equals V initial square plus 2 instead of A, GD. Like S or D equals V initial T plus half GT square. And take care of the sign of G, may be positive or negative depending on the direction of the motion. Let's start to solve some problems about what we got from y. Which of the following statements is true? Displacement is a scalar. Do you remember that we said displacement is the shortest line between the start point and the end point, and it has direction? So this is wrong. Displacement is vector, yes, and distance is a scalar. This is true. Distance, we don't care about when we calculate the distance, we don't care about the direction, the distance between these two bars, 2 meters, we don't care about the direction. We have many quantities in physics are scalar, like volume of a bottle, like area of a room, like temperature, but displacement like this vector quantities like force, like acceleration or velocity. So we got the right answer. Number 2, which of the following is the best description for velocity? Put in your mind that velocity is vector quantity, and any vector quantity has both magnitude and direction, plus magnitude and direction a unit. Velocity equals displacement over time, right? So the unit of displacement in SI unit meter, and the unit of time second, so meter per second. So let's start to solve it. Here the first choice 60 miles per hour. He gives us a number with a unit. The unit is suitable because length over time, as you see, length, displacement is a length over time. So it is right, but hold on, it doesn't have direction, so it is wrong. Second choice 30 meters per second, also it doesn't have a direction. Here letter C 30 kilometers at 45 degrees north of east, it has direction, but the unit is wrong because the unit is kilometer, and the kilometer for length. We have here a length over time, so the unit is wrong, so this is wrong. 40 kilometers per hour, the unit is right, but we don't have a direction. The last one, we have a number, we have a unit, we have a direction, so this is the right answer. Let's move to the next. A jogger runs 3 kilometers in 0.3 hour, then 7 kilometers in 0.70 hour. What is the average speed of the jogger? How to calculate the average speed? Let's get the total distance at the beginning, right? Total distance. Total distance here 3 kilometers and 7 kilometers. 3 plus 7 equals 10 kilometers. And let's calculate the total time. To calculate the total time, 0.3 hour plus 0.70 hour, it equals 1 hour. So average speed equal distance over time, 10 kilometers over 1 hour, it yields 10 kilometers per hour. Do you have this answer here? Yes, letter A. Put in your mind, in some problems he may give you that the object stays or the car stays at rest for half hour. So in this half hour there is no distance, but still you need to add the time to calculate the total time, so you can calculate the average speed. Okay guys, Let's go to the next. A motorcycle starts from rest. Rest in physics means zero, means V initial equals zero, and accelerate to a speed of, so we have a V final equals 20 meter per second. In a time 5 seconds, so you have T equals 5 seconds. What is the motorcycle average acceleration? How to calculate the acceleration? We, depending on what we have, do you remember this equation? V final equals V initial plus AT. So A equals, let's send this on the other side, V final minus V initial over T. So the equation that we will gonna use, V final speed or velocity minus initial speed over time. It equals 20 minus 0 over the time is 5 seconds, so 4 meter per second square. We can write it 4 meter per second also. The answer is letter E. Let's move to number 5. A bus starting from a speed of 12 meter per second. So we have V initial 12 meter per second. Positive. Slows means slow down, means it decelerates. So the acceleration will be negative, right? Because it slows down. 6 meter per second, so V final, as you see, less than V initial, 6 meter per second. In a time T equals 3 seconds. He wants to calculate the average acceleration. A equals V final minus V initial over T. A equals 6 minus 12 over the time is 3, means negative 6 over 3, means negative 2 meter per second square. So the object is decelerating. Means after 1 second, its speed will be 10. After 2 seconds, its speed will be 8. After 3 seconds, its speed will be 6. After 3 seconds, its speed is 6. So we got it. I hope you understand what we are speaking about. Negative 2 meter per second square. Let's move to the next. A train accelerates from rest, so initial speed equals 0. Initial speed equals 0 meter per second. At a rate of 4 meter per second square, he gives you the acceleration. A equals 4 meter per second square. For a time of 10 seconds, so T equals 10 seconds. What is the train's speed at the end of the 10 seconds? So he needs V final. So easy, guys. V final equals V initial plus AT. V final equals 0 plus the acceleration is 4 times the time is 10. So 40 meter per second. Do we have the answer? Yes, here, letter E. Let's move to the next, number 7. A football player starts from rest 20 meters from the goal line. 20 meters from a goal line. Imagine this is the goal line. He starts here 20 meters from the goal line. And accelerate away in this direction at 2 meters per second square. So he gives us the acceleration 2 meters per second square. How far from the goal line is the players after 4 seconds? He needs how far from the goal line from here, guys. So he gives you the time T equal 4 seconds, and don't forget he starts from rest. So V initial equals 0. right, 0 meter per second, which equation will be good to solve it. Let's see it together. Do you remember this one? D equal V initial t plus half a t squared. So if we use instead of ds displacement, so we can use it and write it like that: delta x equal v initial t plus half a t squared. Delta x here means x final minus x initial, right? Equals v initial t plus half a t squared. Move x initial on the other side, so x final equals x initial plus v initial t plus half a t squared. X final here, x initial, it was 20 meter, right? Plus v initial t is 0 because its initial speed is 0, plus half times the acceleration is 2 times the time is 4 seconds, 4 square. So x final equals 20 plus 16 equals 36 meter. Do you have this answer? Yes, to 36 meter. I hope it is easy. Number 8, a stone is dropped from wrist. So V initials equals 0. What is the acceleration of the stone immediately after it is dropped? What is the acceleration after it drops? The acceleration here is the acceleration due to gravity. It equals 9.8 meter per second square because the object is falling, or the stone is falling under the effect of the gravity, pull of gravity. So it is approximately 10 meter per second square. That in the absence of air resistance, guys. Question 9 to 11 refer to the following. A ball is thrown straight upward, okay? With an initial velocity, he gives the velocity initial 15 meter per second. What is the ball's acceleration due after it is thrown? The acceleration is downward and it is equal 9.8 meter per second square toward the center of the earth, right? Or approximately 10 meter per second square downward. The earth pull object toward itself, so the acceleration will be downward, because when the object is going upward, it decelerates, slows down. Its speed decreases uniformly by 10 meter per second each second. So the right answer here is letter C. How much time? He asked about time. Does it take for the ball to rise to its maximum height? When the ball reaches the maximum height, when its velocity equals 0, because when the velocity equals 0, the object start, or the stone start to fall down, or the ball start to fall down. So he gives you from while the initial speed v initial equal 15 meter per second, v final equals 0. You have to notice that from the word maximum height. The word maximum height, so when the object reach the maximum height, its speed equals 0. He needs the time for the ball to reach the maximum height. What do you have? You have V initial and V final, and you need T. But you know that A equal G or negative G, because the object is going up in the opposite of the pull of gravity. So T equals V final minus V initial over negative G. So T equals V final 0 minus V initial 15 over negative 10, right? Approximately. So negative goes with negative, so the time 1.5 second. Do we have this answer? Yes, the last one. Okay, guys? Always the time positive, guys. Don't forget that. What is the approximate maximum height? From the information you have, he need to calculate the maximum height. We can use the motion equation, like you have two equations to calculate, three equations to calculate the height. Let's use one of them. Do you remember that V final square equal V initial square plus 2A D or S or H here, the height. So H equals V final square minus V initial square over 2A. But instead of A, it is negative G, because the object is going up in opposite direction of the direction of the gravity. So V final square equals 0 minus V initial square. Do you remember V initial square? 15, I think. 15 square. 2 times negative 10 means negative 20. So negative goes with negative. 225 over 20 means 11.25 meter, approximately 11 meter. Do we have this answer? Yes, it is here. Let's go to next one. Questions 12 to 14 refer to the following. An object's velocity is measured each second and the data is summarized in the table. Velocity time at times 0, the velocity is 0. At times 1, the velocity after 1 second, the velocity is 2 meter per second, 4 meter per second, 6 meter per second, 8 meter per second. Let's calculate the acceleration. Guys, acceleration is the slope of graph. If we draw a graph between velocity in meter per second and time in second, تمام, you will get a straight line here, and the slope of this straight line dv by dt equals acceleration, right? So we can calculate the acceleration from calculating the slope. So A equals, let's choose any 2 points like this one and this one. You can choose different, don't worry. So 8 minus 0, 8 minus 0 over, rise over run, don't forget, 4 minus 0. So it equals 2 meter per second square. You calculating the acceleration, don't forget the unit, 2 meter per second square. Let's move to the next. The distance of the object traveling during the first 4 seconds. So we have t equal 4, and he wants to calculate the distance d, right? But we have V initial, guys. Don't forget V initial equals 0, right? So easy, we can use this one. D equals V initial t plus half a t square, right? D equals V initial t is 0 plus half times the acceleration is t, 2 times t square, 4 second, right? 4 second square. So distance equals 16 meter. Also, we can use the other equation, d equal v final square minus v initial square over 2a. So v final square after 4 seconds, do you remember 8 meter per second? So 8 square minus 0 square over 2 times 2, so 64 over 4, it yields the same answer, 16 meter. Okay, let's move to the next. If the object stops accelerating at 4 seconds, the previous object stop accelerating while its speed came 4 meter per second. Type. So V here 8 meter per second. 8 meter per second. 8. Okay, guys? So now it is moving with uniform speed or velocity, right? Or constant speed. The distance the object travel between time 4 seconds and 7 seconds. So t equals 7 minus 4 equals 3 seconds. And the object is moving with constant speed because it stops accelerating. So how to calculate the distance here? It travels d equal vt, so 8 meter per second times the times 3 second, second goes with second, 3 times 8, 24 meter. So the object will stop accelerating and move with constant speed, right? For 3 seconds, so 8 times 3, 24 meter. Let's move to the next. An object starts with a speed 10 meter per second, so we have V initial equal 10 meter per second. And accelerate gives you deceleration, negative acceleration, A equals negative 2 meter per second square. Okay? Start with this speed and accelerate negative 2 meter per second square. How much time he needs? T till it comes to rest, so V final equals 0 because it is decelerate, right? So easy, V final equals V initial plus AT, V final 0, V initial 10, right? Minus 2 times T, right? So 2t equals 10, so t equals 10 over 2 equals 5 seconds. And you can calculate it using your mind, guys. I was moving with 10 meter per second, decelerate 2 meter per second each second. So when my speed will reach 0, after 1 second my speed will be 8 meter per second. After 2 seconds, my speed will be 6. After 3 seconds, my speed will be 4. After 4 seconds, my speed will be 2. After 5 seconds, my speed will be 0. So 5 seconds. How far does the object travel before coming to rest? He needs to calculate the distance. We can use any equation you like, V final square minus V initial square over 2a, V final square 0 minus V initial square 10 square over 2 times acceleration, as we said, negative 2, so 100 over 4 because the sign goes up and down, so 25 meters. So the object will move 25 meters until it stops. Let's go to another problem. Questions 17, 18 refer to the velocity versus time graph below. The acceleration of the object between t equals 0 and t equals 4. As you see here, it is a graph between speed or velocity in meter per second and time in second. Okay? As you see, the slope is acceleration, right? So he needs to calculate acceleration between time 0 and t equal 4 seconds. So let's calculate the slope. The slope rise over run, right? Equals 4 minus 0 over 4 minus 0, right? Equals 1 meter per second square. So the acceleration is 1 meter per second square. Okay? Time. Here he asks you the displacement of the object between t equals 0 and t equals 8 equals 8. So from the beginning to the end of the motion. To calculate the displacement, you need to multiply the velocity times the time. So you need to get the area. And here we can get the area under the graph by dividing it to two pieces. This is the first piece as triangle, the second piece as a square or rectangle, right? So displacement equals area under the graph. The area of rectangle, half base, so half times 4 minus 0 times the height. The height is 4 plus the area of this square or rectangle, 8 minus 4 height, to calculate the area of the square or the rectangle, width times length. So the base times the height, right? So 8 minus 4 times 8 minus 4 times 4 minus 0, right? Right, guys? 4 minus 0. So here, half 4 is 2 times 4 equals 8 meter plus 4 times 4, 16 meter. So the total area is 24 meter. I hope you understand that, and I think that is enough for this video. كان معكم مستر إبراهيم سلطان فيزيكس اند كيمستري تيتشر. رب يوفقكم انتم واولادي. لا تنسونا من صالح دعائكم ونشر القناة ليستفيد الجميع.